Well, good morning and welcome to you all for what I hope will be a very collectively intelligent session where we will use all of your brain power and that of the panel and maybe some machines as well to make some breakthroughs. My name is Jeff Mulgan. I'll be moderating. What I thought we'd do before we dive into the session is find out really who is in the room. So I'm going to start off by asking each of our speakers just to give one sentence on how their backgrounds relate to the topic we'll be discussing. They all have extraordinarily illustrious careers, which you can read about online, but just a very quick summary. And then I'm going to find out who we have here. So David, could you kick us off?
Two half sentences.
Yeah.
So I'm a computer scientist, but I've done and still do a lot of work in almost every topic. Humans are part of the cycle. But I'm also the president of the Israel Academy of Sciences and Humanities, which goes to say that it's science and people and humanities all mixed together.
Thank you, David. Wendy.
Right. Wendy Mackay. I started out as an experimental psychologist and then got seduced by computers and did a lot of work with what we call interactive computing. I work in a field that is not as sexy as artificial intelligence. It's called human-computer interaction, and we focus very much on the interaction, what happens between human beings and interactive technology.
Thank you. Illa.
I'm Ilan Rubash. I'm a professor of ethics and computation at Carnegie Mellon. So I study the way in which AI and robotics have social ramifications on power structures in society. And I run something called Center for Shared Prosperity, which is related and rethinks ways in which technologists should have a moral obligation toward furthering human social causes as part of their institutional work.
And Eric.
I'm Eric Sadobier, so I'm the president of the Human Technology Foundation, and our foundation works on the impact of technologies on the human being and the society. So in various ways, it can be art, it can be anti-terrorism, it's pretty broad, but we work a lot also on human-machine interfaces, so this is something which is key for us, the topic today.
Thank you. I'm a professor in the engineering department at University College London, have a background in governments around the world, and have written a book, including a book on collective intelligence. So, can we start off by asking you, how many people in this room are involved on the technical side of human-computer interaction, collaboration, and so on? A quick show of hands. Fantastic. How many of you are involved as regulators, policymakers, managers of this stuff? And how many of you just curious? And how many of you just walked into the wrong room? Fantastic, good, that's a good start. So I hope we can talk in this session both about how to think about these issues, but also about not just questions, but solutions as well and examples. And we're going to hear a little bit later from Illa about Ukraine. I'll give one very different Ukraine example, which may be a sort of paradigm of where we're headed. And many of you will be familiar with this. Within really a week or two of the war beginning in February, the Ukrainian government's sort of citizen digital platform, DIA, was being used for ordinary people to spot Russian tanks, upload their positions to the DIA platform, where AI recognized the exact nature of the thing, and then a group of humans made assessments, which in turn then led mainly drones to destroy the Russian tanks. An extraordinary example of very rapidly improvised human-computer collaboration, which had a very big impact very quickly on the war. And I think the Russians were not expecting it at all. So one of the questions I hope we will get to by the end of this session is, where are there comparable hybrids, assemblies, combinations which could be used on anything from healthcare to climate change to misinformation and democracy? So to get us going, I'm going to ask each of our speakers just to say a little bit about how you think about both the framing of the questions and maybe one or two solutions before we open things up. I'm sort of standing here because otherwise I can't actually see the speakers, and so I will be walking around. But I'm also encouraging them, if they feel over-constrained by their seats, do feel free to walk around as well. Eric, will you kick us off?
Yeah, actually, in this topic of human-machine interaction, I don't know if you noticed that first we started to imagine computers coming from how we imagine the human brain, or we understand the human brain. So this is the way AI works. And then we flipped our mind, and now we start to think about the human brain from the computer's perspective. So we could consider that we can add memory, we can connect them if they're not powerful enough, and so on. And in this way, I'm wondering if, it raises the question for me, which is the impact on the definition of the self, the impact on the definition of who we are. Because as our body is part of the definition, like my skin is the skin of the world, so this is what I am, but my mind too. And up to now, we could have a breach in our mind. I mean, it's called manipulation, but we knew who we were, but now if the thinking process starts to be between different human brains, includes machine and so on, that changes the game, that blurs a little bit the line. And for me, it's first a philosophical question, but that's also a psychological one, and that's also a moral one, because then the decisions which are made are the decision of the human being, several human beings, the machine. If the decision is just to launch a missile or something like that, probably the impact is pretty strong. So I think this is something we will have to tackle with. And also another point is we speak a lot about knowledge, but I'm not so sure that the machine helps us design knowledge. Perhaps it's just information, and we just need to be sure between, I would say, data, information, knowledge, and perhaps wisdom. What's the part of the human being, what's the part of the machine, and how do we have to put all of that together?
Yeah, we still don't have any computers which can quite do wisdom on their own. Despite Japan having a wisdom computing program a few years ago.
Know that, yeah.
Yeah. And just one comment before Hila, just on Saturday, I think it was, Bruno Latour died, the great French thinker and philosopher. And one of his great insights was to say we should see the world as networks of humans and machines, that you couldn't actually separate the self or the human from the network of things around us. And we might come back to his extraordinary work later. Hila, you're going to show us some images.
I will. I have to say, in terms of Latour, one of the most important points he made was side effects. The idea that as we manipulate nature, we cause side effects we don't understand. And of course, we live in that today. And the fundamental problem that I have is we use the word autonomy as a society as if it's good for technology to become autonomous and make decisions autonomously. And in fact, what we're doing is stripping human beings of agency. So I agree with everything Eric said. What I would want everybody to understand is, first of all, complexity. As the complexity of these machine systems increases, their errors increase, and our misunderstanding of how they can make error increases. The systems we create are not autonomous. And when people teach you that they're autonomous, or when they use semantically inflated terms like thinking and wisdom and decision-making, they're mixing simple logistics that these machines are capable of with human conceptions that you fill with your desires and understandings and intentionalities which just aren't there. And I wanted to just recommend, because you brought up drones, there's a book everybody should read by Grégoire Chamaillou in France named Drone Theory, which does an excellent job of showing when you make drones autonomous, here's the side effects it has on society. And the problem is one of communication, understanding the scope of what happens in the world. As Eric said, fundamentally, it's about engagement and interaction between machines and humans. The best designs we have are ones that increase personal human agency rather than concentrating power in the hands of an already powerful corporation through information attainment autonomy. And so I had two very quick images for you to give you a sense of that. We've been working for about a decade on a project called Earth Time to help policymakers and leaders of institutions and governments understand how the world is changing. Could you
put the images up on the screen?
The first one I want to start with, I have to explain it to you, but you can show it while I do that, is Ukraine. Thank you. We have about 3,000 layers of data from across the world, but this is just simple data. One example for you. Every dot here represents a human being leaving Ukraine, thanks to the United Nations High Commissioner for Refugees. We get all their data from them on inter-country migration. But the story we tell to decision makers is to show them this refugee flow information, and then to zoom out. And if you play the second link, please, that's global refugee data flow. And what gets really interesting is when we talk about Syria and the fear people have of Syrian refugees going to Europe, or when we show Ukraine, what people don't recognize is the massive amount of migration not involving Syria, not involving Ukraine, that we simply don't talk about in the global south. When we show images like that, massive data analytics and AI combined with human understanding, then we provide agency to human decision makers to make better decisions. And that, to me, is the thesis of what I want to say. Stop giving autonomy to machines and start designing machines that work shoulder to shoulder with us to give us greater agency and peer relationships in society.
Yeah. A huge number of scientific breakthroughs and indeed social breakthroughs begin with seeing things in a different way. Back to microscopes and X-rays and social statistics. Wendy, over to you.
That's a wonderful transition to what I wanted to say. So, as I said, I work in human-computer interaction. I work at INRIA. I'm a research director at INRIA in France, which is the French National Research Agency for computer science. And most of my colleagues there are computer scientists. They're trained as mathematicians and engineers. And they're not trained to think about human beings, which is my own training. And so what we get a lot of artificial intelligence systems that are designed and measured based on the quality of the algorithm and not on the quality of the interaction with the human beings. And if you don't think about the interaction with human beings, you don't create good effects for people. And so one of the key things that's missing when we talk about artificial intelligence is not only what you were saying, where we use words like intelligence and thinking, and so that's not what's happening. These are massive data processors that are thinking about how to calculate stuff. And a lot of AI is designed with a very old model that dates back to the 1700s, the Jacquard, loom, and punch cards, and it's what we call batch processing. We ask a question, it calculates some stuff, and it sends back an answer. And that is assumed to be thinking. And yet, what we as human beings want are partnerships of some sort, where we do what we as human beings do well, which is interpret data like that, and machines do a lot of interesting calculation, but we also want much richer ways of interacting with the world. When we interact with the physical world, we have what we call technical reasoning. We can look at the properties of an object, and we can interpret its properties and figure out what we can do with it. So this is a pen. It's designed for me to write, but it could also be used as an almost straight edge. I could use it to tie back my hair. I can take advantages of its properties, and we as human beings are very good at doing that with the physical world. But when we design technology, we forget about all of that. We create a lot of very arbitrary, very difficult to understand ways of interacting. And my argument when I talk to my colleagues in AI is we need to actively engage in both creating these interactive systems from a human perspective and also measure the impact on human beings in the microsecond, short-term, mid-term, and long-term. So we think about upskilling people rather than de-skilling or replacing them. So,
thank you. David.
I was once at a meeting where a person came about an hour late. And when he walked in, we asked him, what do you think about the topic? He said, I agree with everything that was said before me. So this is, it's great to be the last here because I agree with almost everything that was said. But I do want, with my role as president of our academy, one of the main roles is consulting to government on issues related to science. And I find myself again and again and again hearing everyone talking about AI and cyber and quantum and cyber and AI, and they forget about the people. And now I'm not yet talking about people in the loop, as this session is intended to do, but just people and the basic knowledge and culture and ways of rational thinking that human beings have to have. And my argument there is always, we have to spend money on this too. And one of my hobbies lately has been to collect anecdotes about people's ignorance in issues related to science and to general culture. Someone said to me the other day, oh, global warming, that's not a problem, just put an air conditioner in every room. Someone else said, oh, French Revolution, that's when Lionel Messi moved from Barcelona to Saint-Germain. So these are the kinds of things that one half of me deals with all the time. On the other side, as I said earlier, I'm a computer scientist. I've been at the Weizmann Institute for 42 years, and everything I do, almost everything, deals with these kinds of issues. And one of you mentioned knowledge and information, wisdom even. You mentioned interaction and the basic paradigm of input, computation, output. So there's a paper from the 1980s which I recommend that you look at, in which we define reactive systems as the ones which are much more subtle and relative to what we want to talk about here. But I just want to throw in one word which I hope I'll have time to say a bit more about, and that is that when we talk about humans, it's not only the interaction with the machine, but it's also the way we communicate. And just to give a teaser, if I were to be transcribed now, and everything I said was to be written accurately by a machine or by some human being, and you were given the text, there's still a tremendous amount of information that I am conveying to you and that we're all conveying to each other, which is in the music, the prosody, the intonations, and this is a topic that I'll be happy to say something about, and this goes to the very heart of the ways human beings communicate with each other and the ways they are already and will in the future be communicating with machines. And it's not only buttons and sliders and rules and keystrokes.
And I think there's a wonderful graph of how much information is lost as you move from face-to-face through video to telephone to email, which is why emails are so often misunderstood emotionally when you receive them. Now, there are seats at the front. There are 5 seats on the front row, if any of you would like to come and sit down. There's a seat there and a seat there, so 7 more people can relax.
You can move my little bag from over there.
Yeah, so maybe I'll take this bag off. Ah. Am I allowed, is anyone allowed to sit there or not?
It's going to be up to the technical team as to whether or not it's fine, but some of you may be obscured from the camera if you're not worried about that.
If you want to be anonymous, sit down.
Yeah, and maybe just sort of slump slightly in your chair.
If you're small, you can come.
Short.
Yeah.
No one tall allowed in the front row. So look, I hope we can actually pick up on all these points, and then we will also get on to what this means for diplomacy. But first, perhaps we could just focus on an issue which several of you have raised, which is supervision. So first of all, there is human supervision of the AI. As far as I'm aware, all the drones in Ukraine have had supervision of their firing decisions, but of course there is a future where they make those decisions autonomously. So your observations about the human in the loop questions, where is this really important, problematic, and so on, but also the inverse, when actually do we benefit from AI supervision of humans? If a doctor is making a decision, is it good if there's an AI saying, are you sure you should do that? Or a judge is making a sentencing or probation decision, there's an AI which says, you look pretty biased in that decision. Where do we want to go in terms of these new architectures of mutual supervision? Maybe, David, you might start with that, and we'll...
Yeah, well, maybe someone once told me that if you give a speech and you don't say something quite outrageous, no one is going to remember anything. So my outrageous statement is, beware of AI when done alone. So do not rely on systems which are just simply pure AI. And the issue is not only human-computer interaction, which of course is very important, but the issue is there are so many systems in which human classical model-based software and systems engineering using human beings' expert knowledge is crucial. It's crucial. And so, for example, by the way, it's curious that a non-autonomous car, the interaction with a human being who takes a much larger role than in an autonomous system, is just so easy. I mean, driving a car is easy, even if I have this cruise control. I know what my role is, I know what the engine does, I know I don't do the air conditioning, the car does that, and so on. When we get to autonomous vehicles, and assume that they are already here, which they're not, the interaction with the human beings is just so much more complicated. Not just the ethics of what happens after an accident, but whether a human being in some control room will finally take control. So the issue of this panel is going to get a lot more difficult when systems are so-called autonomous and don't use human beings than when they do use human beings. And when I say beware of AI alone, I mean that we have to find ways to technically, algorithmically, be able to build systems where parts of the reasoning are done using AI. For example, an autonomous vehicle, I assume the AI, among other things, would recognize traffic signs by learning, what is a stop sign under various angles and lighting conditions and so on. But many things will have to be programmed using classical software engineering programming techniques because they're not amenable to just learning. And the technical issue for people like me in computer science is not only helping decide which are these and which are those, but how to mathematically and algorithmically make it possible to connect these two parts of the software engineering process together seamlessly. So
can I ask for a quantitative prediction from you? Facebook in the last 5-10 years has had to employ tens of thousands of people to supervise communication, hate speech, and so on, to supervise the algorithmic decisions. Will the big autonomous car companies have to employ armies of people to be keeping an eye on whether things are going wrong, or will this actually be all automated?
So you're asking me?
Yep. I want a precise number.
No.
Those people are called drivers. I mean,
Yeah.
No, this is a different role. This would be in a headquarters.
I don't understand numbers, but I don't want to try to be to make a prediction. Although this conference is about prediction and anticipation of the future science, I don't want to do that. We have a saying in our language that prophecy is given to the fools. It'll be difficult, that's for sure. And the fact that numbers count is very, very important. I have someone I know pretty well who didn't go to vaccinate himself, and I had this argument with him, and he said, I can give you stories about people who've been vaccinated and so terrible things happen to them. So I said, why do you cross the road? I can give you examples of people who cross the road and terrible things happen. And he said, well, it's different. I said, yes, it's different. The numbers are different. The probability is different. And he closed the argument by saying, oh, you scientists with your numbers again. So I don't want to give you numbers.
Okay, Wendy. Yeah.
All right, so I want to fundamentally challenge your question.
Great.
Because there's an assumption hidden in the question, which is there are these intelligent systems, which may or may not have the ground truth. I would argue they don't. But it's often assumed that, for example, there is a correct diagnosis for this X-ray, and that a good AI system will be able to figure out, yes, it's cancer, or no, it's not. But the assumption is that somehow figuring that out, whatever that is, and then telling the user, the human being, the doctor in this case, is the right way to frame the question. And what it misses is the fact that when you give people information, it changes the way they interact in the world, okay? And it's the interaction that matters. So there's a danger in giving radiologists information and telling them it's probably this. So the exact same interaction, I'll give you an example from the American Navy, where they built a very clever intelligence system to help people navigate into harbors, which is a very difficult task, and generally you need an expert to do that to help you get in. And they tried an AI system that said, this is the best route, and within a matter of weeks, people completely rejected the system. And then they shifted it, and they said, okay, you create the route, you, the human being, and then the system will give you various alternatives and their pros and cons afterwards. So it shifts from I'm going to direct you and tell you the right answer, to you think about it, you develop your experience, and continue developing your experience and all those intuitions that you as a human being do by making those decisions. And I will give you help and additional things and points that you might not have considered. So I'm going to make you better.
Is this the future of Google Maps, do you think? Personalized?
Well, it should be,
Yeah.
because Google Maps is it's getting worse and worse, actually, not better. And so again, this is an example of this idea that the interaction matters, and that there's a principle that comes out of evolutionary biology that's called co-adaptation. It's not co-evolution, co-adaptation. It's like co-evolution. Co-evolution you see in terms of the fact that we, on this planet, we're changing the atmosphere. There used to not be oxygen in the atmosphere, and then you get anaerobic bacteria that give out oxygen, and then that creates an atmosphere, and then other organisms evolve to create That's co-evolution. Co-adaptation is more on a human or individual animal scale, and it's how we adapt to the environment. But the key point is we do not simply respond to the world as it is. Of course we do that. We learn about it. But we also change it. We adapt it. We appropriate it. And we use technical reasoning and these other principles from psychology and other fields, and it helps us interact in the world. And if we're not designing interactive systems, we should not, I completely agree with you, David, that we should not be thinking about AI as if there's some kind of font of knowledge that gets created and it just gets handed to users and we don't care about what that interaction is. The fundamental thing is a pretty stupid little algorithm can have a much better impact for a user than an extraordinarily sophisticated one, if the interaction makes sense.
Yeah, fantastic. So, both either supervision or conversation between human and machines. Tell us your thoughts.
So I'm going to build exactly on what Wendy said. I love her answer. There's 4 huge dangers with supervision that I want to point out, and then I'll talk about the other side of AI supervising humans. One of them is what I call attentional deficit. Here's what we do. We decide, okay, it's going to be a drone, the autonomy is going to make some decisions, but the human's there to review the decision. Then later we say, well, the drone's making a really fast decision, so the human will have 5 seconds to respond and there'll be a button they can press. Then later we say, well, the drone's making a decision that's a little too fast for the human, so trust us.
Yeah.
And this exact same thing happens with cars. We say, it's an autopilot, it's going to drive on the road, please pay attention in case the autopilot doesn't know what to do. So now what do people do? They don't pay attention. And then exactly at the one moment when the autopilot doesn't know what to do, which is precisely when it's snowing, and the car in front of you is spinning out, you're supposed to take over. In that moment when you're actually thinking about something else because you're not driving. So the slippery slope that we have is that we constantly cede authority to the AI system, thinking that we're supervising it, but we cross barriers where our supervisory ability becomes attentionally impossible. And that always happens if you let engineers run the day.
So what's the answer to that specific design challenge?
You have to optimize a different thing. You have utilitarians saying, oh, the best thing is to minimize total deaths on the road come what may. Instead of saying we need to think about character ethics and the value and agency each person has in understanding the machine they're operating.
What does that actually mean for the design of the car?
It means you have to maximize agency for the human because of the other 3 things I'm going to say.
And stop them ceding it to the
You have to stop ceding control.
Okay.
And
Yeah.
this comes to the other thing I was going to say, which is the kind of errors you have aren't human. And we miss this. Supervising a human being, I can supervise my daughter driving because my daughter is a human being. No news there. Me supervising a robot driving, or more importantly, me supervising a light speed stock and futures trading system as somebody who works at JP Morgan Chase is a disaster, because the type of errors it makes have nothing to do with the types of errors humans make, and therefore I don't even know what to look for. I'm not primed to understand it. I'm also not the engineer. That's why a pilot of a 737 MAX crashes, because they don't even understand the error models governing how it makes mistakes, much less how quickly to turn off the autopilot. And in the case of the car, just one example for you, this paper has been passed around too many times already, but you take 4 little pieces of electrical tape on a stop sign, and every computer vision algorithm thinks it's a 45-mile-per-hour speed limit sign. It's not the kind of error human beings make, and therefore if your car approaches that stop sign, which looks like a stop sign to you, with some graffiti on it, never will you think, I better put my foot on the brake and get ready to stop because it's going to breeze through the stop sign. That will never occur to you as a human, so you're a really bad supervisor, actually. The other 2 I wanted to point out quickly, one is confirmation bias, which goes with what Wendy was saying. If you radiologist is going to start depending on that system, they're going to start making the same errors as the system. The bias will feed back into the supervisor. The last one is explainability. As engineers, we'll make black boxes because they're 1% better than the system that was explainable. But every time we make the system more opaque, it becomes more difficult to understand why it's making the decisions it's making. And we see this in mortgage lending in the US now, where the mortgage experts can't even explain why the mortgage lending system is reducing the number of acceptances it's making to African Americans. They don't even have a way to answer the question, why is there bias in the system, because they've made the system too opaque to do so. I will give one positive example on the other side, which is AI systems supervising humans, which is sometimes that works well because agency rests with the human. And Mercedes is the example I'll give. When it's mathematically determining in the car that you're going to crash, the human has failed in their ability to drive the car, it maximally applies the brakes, therefore minimizing chance of lethality. Great. That's a computational system making a decision as your supervisor when you've clearly lost the game.
We might come back to your previous point on opacity, because the European Union's new AI legislation says that every algorithm should be explainable, but it turns out, of course, no one can explain most algorithms, including the people working on them. If anyone in this room can explain Google search, please tell us all later. Eric, and maybe take us to one other domain like art. You were going to talk about art a tiny bit.
Yeah, just to come back to your example about the car, I mean, I had a conversation with a team developing those autonomous cars, and they say we have a problem because in the beginning we started to have like experiments with some employees of our company saying, oh, you have to pay attention. And they put a little camera into the car. And after 2 weeks, people were sitting in the back with a newspaper, and they say, "Hey, drive me to the office," and that was okay. So actually, we need to be sure that the human being I would say, keeps the attention. And I would say that on this supervision point, I mean, we're already partly supervised by machines, and we can see that in warehouses and so on. So we work with. I'm a member of the French Digital Council. And we worked a lot on the impact on the mood and the mindset of the employees. And we see that this is a disaster because very often, even I would say, people working in a warehouse, for example, they have their own skill and they have their own pride in the way they do their job, like putting all the stuffs in the best way in a container and so on. And when the machine says what you have to do and how you have to do it and when and so on, it kills all of that, and it kills even self-trust, and all of that is a disaster for human agency. So I think that and I like what you said about co-adaptation, and there's a lot of work to do just to be sure that the human being will flourish in such a context. Otherwise, we'll have a kind of digital proletariat working for a machine and some other people having a machine working for them. And I think this is not the kind of society we want to develop. And the other point, I agree with you, it's not easy to supervise a machine. So I would say at some point we need to reshuffle the way we interact with the machine. And as you said, what's happening currently in art is interesting. Probably you heard about DALL-E 2. So this algorithm, which allows from a prompt to draw something or build an image. And actually, it's very efficient. And now alternatives exist also for videos and music and so on. And probably it will challenge the way we see our creativity and our creation process. A little bit like when photography came. In the beginning, if you wanted to have a portrait, you needed to ask to a portraitist to do the job. Then you could ask to a photographer, and the machine did part of the job. And now the part done by the machine is bigger, but it will challenge all the artists to, in the way they will probably have to change the way they do their own art. And that can be very positive for the human being, because probably it will allow us to develop like new branches of art, and that will improve our, I don't know if it will improve our agency, but at least it will improve our ability to do new things.
Yeah, fantastic. Quick comment from David, and then I'm going to open up for comments or questions from the audience.
A quick comment. So a couple of you mentioned explainability problems with AI systems, which are obvious. You cannot explain a deep neural network. But what is even more serious is our inability to verify pure AI systems. And verification is a very rich, very deep, and very productive topic in computer science. There is no way, as of yet, to verify even a simple deep neural network, even probabilistically. There are attempts to do so. The best you can get, and if I go back to my comment earlier about the need to build systems which are made part from AI modules and part from classical programmed model-based modules, the best you can hope for is what I like to call relative verification, is you can hope for and maybe even work out a formal mathematical proof of the correctness of a system, assuming the correctness of the AI modules. And this can be defined mathematically, and in principle can be carried out mathematically. And until and unless we have ways to actually verify the AI components, we cannot hope to do better than that. And that is a lot more serious than not being able to explain Google search. It's not being able to verify that 98% of the time the autonomous vehicle will make the right decision, which is terrible.
Yeah. Really good example. Right, either facts, comments, or questions. First of all here, then in the third row, is there a mic? Here and here. So you keep them pithy so we can cover as much ground as possible. And just one example of digital proletarians. I mean, Uber drivers, at least in my country now, do not know why they are being paid the amount of money they get for each trip. It's designed by the algorithm, and the company refuses to tell the drivers why they get what they get. So this is now, not the future. Yeah.
Thank you. My name is Tamara Gomez. I'm a Costa Rican diplomat. And listening to you, and sometimes I see like AI, some kind of religion and faith, and so much is deposited, and then we want to introduce AI in our daily lives. But you explained it really well that they are sometimes algorithms are biased, and in the end we have humans program these algorithms. And I'm sorry, I'm wondering, should we change something in the curriculum of the universities, or what should we change? Because in the end, we're going back to the humans. So it's not like mathematicians and psychologists meeting each other and discussing if humans should be in the center of AI. But we are training and educating these people. I mean, well, I'm not, but the universities have a role there, and the curriculum has a role there, so that we can direct AI to really help humans to thrive and to move to another level and not taking away our humanity.
Fantastic. Just behind you, and for what it's worth, this is my university and others are completely redesigning courses in this way. Silicon Valley, all the big companies worry their engineers have no sense of history, ethics, all the other things they need, and they realize now this is a problem. Yeah.
Thank you. I'm very sensitive to the autonomous car problem. I have a Volvo that does a lot of stuff for me, and as the human that is supervising my car, as was said by Eric, I often see things that happen, like the fact that I'm driving at 130 on the highway, and suddenly it sees an exit sign, and on the exit sign there's a 90 kilometers per hour limit, and it fails to recognize that this limit applies to the exit, and suddenly it brakes to 90 kilometers with people behind me, which is quite stressful for everybody, me included. And I think what's happening here is two factors. One that joins the stop sign with stickers. Our cars today are using technologies to examine their environment, which are not our technology. So we can't supervise them for what a LiDAR sees or what a radar sees, or something like that. Tesla is just removing all the LiDARs from their cars and just switching back to cameras. That might actually solve a lot of these strange behaviors, because the car will start seeing things the way we see. I don't know. LiDARs bring additional information, like obstacles that we can't see because they're in the dark.
LiDAR's just
But what I think is important, and I'll finish with that, is that the cars yet don't have all of the context. With context, the car wouldn't see the 90 sign and interpret it the way it does. So we need a lot more information and context for the AI to work.
If you could pass the mic, I think at the end here, and there's a general question, all sort of logic models, that sometimes making things more complex makes them less efficient, not more efficient. You get this in central banking and marketing and lots of other fields, and I think, Wendy, you alluded to it. Here, at the end of the row. I think you had a question.
Thank you to all the panelists for a great discussion so far. I just want to know, what do policymakers not understand about how algorithms work? And what can they do to engage more constructively? Where's that gap, and how can they engage more constructively with technical experts towards working towards algorithmic regulation and bias reduction?
Fantastic. And then here, and then I will ask you actually to maybe address these questions of what's the quick way of getting the right kind of curriculum, essentially, whether for students, engineers, or policymakers. Yeah.
Olivier Ollier, I develop and commercialize brain-computer interfaces. Two questions. What do you think about the European Commission wanting some transparency and explainability on how algorithms work when they do not ask the same question about humans? That's the first point. And second, there is a common theme in what I heard from all of you, that, if I understand well, we need to debias AI.
Why? No.
Biases are not the exception, they are the norm as humans. So you want to debias humans as well?
Okay, can anyone in this room explain how they work? Sorry, that was a joke question. We do struggle to explain how we work. Right, some answers. Maybe start with you, Eric.
Yeah, just to start by the latest question, I would say the point is not to have a full transparency on how the algorithm works, but to have the same level of explainability that we can require from a human being. I mean, if you ask for a loan and it's refused, you can get some answers from your banker, and the same for different kinds of decisions. And I think this is key that, I mean, we don't pretend to debias the human being for sure, and probably the machine gets our own biases, but the point is just not to add biases on biases. And unfortunately, currently, so many people feel like they are lost, and I mean, they don't get any answer from on their questions. And so, I mean, that brings to some of the social movements that we have, people consider that they are completely out of the loop. And I think that's something we need to fight. So I agree with you, probably we cannot do everything, but I'm sure that there's a minimum that we have to do, otherwise we will have no social acceptation, and the kind of technology you develop will be rejected. That's my
30
point.
seconds, Wendy, on the curriculum. How do we prepare people appropriately?
So there's a movement now on what we call human-centered AI. And the idea is to bring together people with backgrounds in psychology, sociology, anthropology, design, and engineering and mathematics and so on, and bring them together. And the idea is, if you know about people, to create something that has an impact and implications for the design of interactive technology. And if you know about building technology and algorithms, you have to do something that you understands how you measure its impact on human beings, either short, medium, or long term. And so the idea is that you want to change the curriculum so that people are fundamentally involved in this cross-section between the two. It's not that we are going to take mathematicians and make them good anthropologists. That's not a good use of human beings. But it is important that we create an environment in which they understand that there's a different value system, a different set of skills and knowledge that they can use to apply to any question, and be able to develop the communication among the people who are designing these systems. And that, I think, is starting in various European countries and also in the United States, although I would argue slightly less so. But it's hard because, particularly, at least in my experience in France, France is very, very proud of its ability to develop very technically competent and mathematically brilliant computer scientists, and those people are not particularly interested in wasting their time with these people. And so it's quite a shift culturally to get the universities to shift that perspective, but it is happening.
Thanks. David, you do waste your time with these people, don't you?
So in terms of the curriculum, I agree with what you said, Wendy. But again, beware of throwing away the baby with the water, as they say.
Yeah.
Please, please do not encourage your governments and your education ministers and your university presidents to have completely new topics. I don't want an academic degree in AI. When relativity theory came up, when quantum mechanics came up, no one replaced physics with a degree in quantum. And I'm hearing voices like this already. Oh, AI is so important. We need to train AI people, give them the ethics, the psychological aspects too. Take the computer scientists, shake them a little bit so that they burst a little bit out of their own cocoons, but do not ruin the basic criteria. Physics is physics. Computer science and systems development is a topic. AI is part of that, has to be enriched and so on. Don't exaggerate. Don't go too far in saying, oh, this is new, we need a whole new curriculum.
So deep groundings in knowledge still matter.
Yes.
That's what universities are meant to do. Now, in our final few minutes, I'm going to ask you, Ila, to kick us off on this bit. I want us to turn to kind of GESDA territory. What does any of this mean for diplomacy or global governance? We have a whole series of sort of semi-intelligence platforms out there, like IPCC on climate change, ITBES on biodiversity, the WHO sometimes on pandemics. Where might these go in the future so they combine the kind of observation you were showing, Ila, with interpretation, feeding into action, feeding into learning at a global scale, and presumably always with some combination of machine and humans? What's your vision for the future? And anyone else in this room would like your visions too.
My vision for the future starts from the fact that what you're seeing up here is a small minority. If you go away from this thinking this is what technologists say and think, the reason the policymakers make so many wrong decisions is because the majority of technologists that they do talk to and consult with today are techno-optimists who believe we're heading toward a post-human future, that if AI is wrong today, it'll be right tomorrow because we'll just spend more time on AI and we'll make the computers do a better job, and it's going to save us from climate change. It's going to save us from its own power requirements. Don't worry, everything will be okay because technologists will save the day. Anthony Lewandowski, talking about religion, not only did he say the quote that Singh said yesterday about history doesn't matter, only the future matters, he's the same guy who has now founded the Church of the AI Godhead in Los Angeles. I'm not kidding, look this up. Oh. So if I look at the future, what we need, and it goes back to curricular and to what David said, we need, and by the way, my philosophy friends, half of them see this wrong because they also talk to the same techno-optimists. So they think, even from an ethical, philosophical point of view, they hear people telling them, oh no, my computers are going to make moral decisions. So they're going to do a better job with moral decision making than humans because they don't have bias, they're computers. So if you're going to solve all this, we need a kind of transdisciplinary engineering moonshot, where the engineers and the philosophers and the philosophy of science historians actually work together to design the systems, and the policymakers listen to the right group of people. They have to stop listening to the wrong people and listen to us instead. If you can get that to happen, then we have a shot at this.
So 2 kind of follow-up questions for all of us collectively. One is a money question. So it's actually quite hard to know exactly how much money has been spent on AI R&D this year, but it will be in the many tens of billions in the big companies, from the Chinese state, from most governments. The amount of money being spent on research on what we're talking about here is probably 0.1% of that. If it is, there's a massive imbalance. And that's often because the politicians don't really understand these issues, and they, I've worked for many of them, they sort of hide their ignorance by becoming techno-optimists. So how do we deal with that distortion of flows? And then the institutional question, where might these tasks be embedded? So the IPCC was in some ways a great breakthrough on observation, but whereas we have a World Bank, an IMF, all sorts of money-based institutions globally, we essentially have none with the skill, capacity on the sort of things we're talking about here. So presumably the diplomats of the world will answer that question. Does anyone in the audience want to say how we fix this problem? The 1940s focused on cash, money, that was dominant. The 2020s, surely that's a very anachronistic worldview. Or do any of you have a blueprint to share? David, let's skip you.
I said earlier I don't understand numbers. I definitely don't understand money. But, but I'll take the opportunity just to say 2 sentences about a technical challenge which I think should be somewhere on the horizon of the scientists doing AI and doing computer science. And I'd like to call this, I haven't even written about this before, so this is a scoop, the immersive Turing test. So I'm hoping that people know what the classical Turing test is, where a machine is deemed intelligent if you put it in a room and you put a human being in the room and a third human being in the third room. The third human being cannot really tell the difference between the computer and the human being just by communicating with keystrokes. If we want to communicate orally, it's a whole different story. Exactly. I would like to suggest that what we're looking for, if we want to know whether a system is really intelligent today in the realm of systems, and exactly in the realm of the topic of this panel, which is humans interacting with systems, we need an immersive Turing test where you stick the piece of software you think is intelligent in the exact same environment it's supposed to operate in, with, say, an autonomous car, and someone on the outside cannot tell the difference between a system which has the human-made AI inside and a real human being inside making these intelligent decisions. So it's a variant of the Turing test where we stick the proposed intelligent computer or piece of software into the environment. We immerse it in the kind of environment where it's supposed to behave, and then you cannot tell the difference. It's not something we want to try to conquer, but it's something to keep on the horizon when we talk about intelligence for the future systems.
Immersive, embedded Turing test. So we got a question, first of all, at the back, and then on the third row. Yeah.
Thank you. So, Quentin Ladeto from the Swiss DoD. I just have I mean, I don't have the solution to where that the money must flow, but when the AI will materialize on product, on the market, normally there is a certification path of the product. And could that be a possible moment in time where we can force to move from a black box to a white box and understanding what are the relationships and what the consequences to the relation between the input and the output, and at that moment that we try to prepare and support this kind of human-machine interaction by just the test that the product must comply with before coming to market.
Okay, and bring the mic to here. There's a lot of work underway on AI assurance, and there will be probably a huge industry of AI assurance. Whether that will deal with these human interaction issues, I'm a bit skeptical, but let's, yeah.
So thank you, Anne-Marie Bizatu from ICT for Peace. I'm also not going to try to come up with any kind of financial or money figures on this, but really coming from a governance perspective, which is something that we work very much on as well. One thing hearing you, there are errors that the machines make, and they are different often from the errors that humans make. And like, for example, the cars driving down the streets, they see signs that are developed for humans, not for machines. So in this case, we have different kinds of errors. So when we talk about governance and how do we craft the kinds of governance frameworks to actually understand these types of errors or that machines make, that humans make, isn't maybe this idea of translating better these errors in a format that we can then, as humans, understand. And I think that would also mean really reorganizing our governance and oversight structures, which is something that also, even just now, I run into all the time. I work on one project, and in a government administration, 3 or 4 different divisions will all have a piece of it because they're not organized around the way that information is flowing and the challenges it's posing. So just more of a shout out of like, how do we reorganize governance to actually meet these challenges and supervise effectively these kinds of systems, these human-machine systems that are now coming into existence?
So there is a huge debate underway on assurance, audit, regulation of algorithms. Yeah. And indeed, every European country will have to create a new regulator. We've got one in the UK already from a few years ago. But that's about stopping the problems, the biases. I would like in our final 3 minutes to focus on the positive. What could we take out of good examples? And you've all given some. We began with the one on Ukraine and the DR app and so on. Could you each maybe say a little bit about what you would like to have happened in the next 5 or 10 years, which is actually good examples of using human-machine collaboration to solve problems, make the world a better place? Who wants to start? Wendy, yeah.
All right. 3 minutes. Oof.
1 minute.
1 minute. So, certification in safety critical systems is very, very difficult with AI, and I think part of the problem is the question is framed incorrectly. The idea is we've got some sort of static correct answer or not, and we certify that, and that's not how it works. There's an interaction over time. It's a process. So as a human being, what we want is a system that says, what did you interpret of my behavior, and what is possible for me to do now? And so we're working right now in, I'll just say, aviation, and working with pilots in cockpits, and the idea is to create a partnership between the users and the smart systems and try to think about how the system cannot explain this is right or this is wrong, but what did it interpret and what's possible next, and build that in a cycle. And it's this reactive process that you were talking about before, and sort of shift it so that we're thinking about not an absolute certification, but a creation of an interactive process over time that we can then certify. And I think we can do that. And that's a smaller goal, but it's much better at meeting the needs of users and keeping the motivation there. It upskills them rather than deskills them and so on. So think process, not absolutes, and you'll get further.
Great. David.
So 2 topics briefly. First of all, a project that we've been calling Wise Computing, which I think is doable within the next 5 or 6 years, is not to use AI for some application area, but to use AI within the process of developing a system. And so my dream is to have a team of engineers working on a system, and the computer we're working on is not just taking notes and remembering things, but goes home and makes all kinds of predictions and comes back the following morning and helps us in our design. I don't have time to get into it. We call this wise computing. You can look up a paper that we wrote on this. And the other thing, to get back to my earlier comment on prosody, the intonation of speech, I'm working now with a team very, very hard to try to extract from human speech the modalities, the feelings. So to be able to tell the difference between my phone is ringing, or my phone is ringing, or my phone is ringing, which have completely different meanings. Yeah. And this is not just like an amusing example. I mean, even when I call my healthcare provider and I say my tests have not arrived, and there's a bot on the other end, the bot should react differently to my tests have not arrived, and my tests have not arrived. So if I'm really angry, they should do something quite different. And this has enormous amounts of implications. And as I said earlier, it goes to the heart of the communication that human beings do with each other. It's not just keystrokes and working with a machine or immersed in a machine. It's the way we communicate with each other by speaking and hand waving and gestures. And no one has almost an inkling about how to do more than just speech recognition and writing down the words that we all say here.
Fantastic. Ila, wave some hands.
My silver lining is something I love, which is you can use AI to invert hegemonic power structures in society. I've seen it happen. You take community organizations, you give them AI, and air pollution, huge problem in the US. We had a community of 70,000 people being toxified because of a Coke plant that refactors coal into Coke in Pittsburgh. They used AI to automatically create machine vision systems that capture all the illegal emissions. They dragged the EPA in, they closed the plant, 50% decrease in cardiovascular disease, 40% decrease in asthma across 70,000 people, because the community learned how to take AI and create a counter narrative against industry having power and authority to say, no, we're not polluting the air, and trust us. Yeah. So if we can do that and use it ground up, then AI can actually be a force for good in society.
We actually use clean air in India to train students on how to think about data engineering and politics in an integrated way. It's the perfect topic because we've got so much data now on air. Yeah, Eric.
Yeah, so to build on what Ila just said, I would say that in the way we design public policies and also we flag the investments, about using money, the questions you were raising, previously, I would say the question is less how we do that, so about the characteristics of the system, than why, so the goal. And too often we consider that AI is good in improving the efficiency of our systems, and it is true. And so we just improve the efficiency, but we don't improve the resiliency of the system. And we've seen with the pandemic that, unfortunately, our system is so efficient, our supply chains are so, everything is very complex and so well organized that if there's a little problem, everything blocks, and the factor of resiliency is just the human being. He's stuck, he's locked down, he cannot go to work, and so on. And I would say that we should shift the paradigm and say that the goal is not to improve the efficiency of our system, can be political, economical, and so on, but to improve human flourishing. And I think that improving this resiliency in the way we design the system is quite a challenge, technically speaking, but this is the key if we want to have a real human-centric AI.
Fantastic. Look, we're out of time. I'm going to give Thomas, if you want, a moment to say something. Just two final things from me. One is, I think, as you've heard from this panel, what we're talking about actually is the new mainstream, the new normal. Almost every field we depend on, from aviation to finance to democracy and media, will require new designs of combining data, AI interpretation, human interpretation, judgment, and so on. And this is the next challenge. It's not just about automation. It's beyond automation. And just one comment on David's point on wisdom. There's a very interesting thing, I think, which is very relevant to governments. The basic idea of Thomas Bayes, of Bayesian thinking, which underpins much computation AI, is that you try to predict what you think will happen. You then look at the data, what actually happens, and then you learn. You adjust your model. Now, that's almost a definition of wisdom. is surprisingly rare in governments and public institutions to actually do it. But there's in a sense, there's a read across from the way the best machine learning or deep learning works to actually how we should want all of our institutions to work in the future. Thomas, final comment from you.
Oh, I didn't have a final comment, but I will. but I will say that my only comment would be, I guess, is if we're going to have an autonomous vehicle that's going to pass the immersive Turing test, it will have to speed between traffic cameras, tailgate, stop at too long at the red light while texting while driving. Right? It'll have to do all those things, or I will believe that it's
screaming at the other drivers.
Exactly, you have to have a megaphone. Otherwise, you're never going to believe it's a human, right?
Thank you.
But thank you all, and I think there are some refreshments as well, and then there's a break, and then we will be on for the next sessions shortly. So thank you all for being here.
Thank you all. Yeah.
Thank you very much.